Hey guys, today we're going to talk about the third and final method that we have for graphing quadratics. This is called mapping notation, and although I think personally I like step pattern better, I do think this is a close second. It's another great way to help us graph quadratics quite quickly and easily. It's maybe not as fast as the step pattern, but in some ways it's actually a little easier. So anyway, what we're going to do is we're going to have to use a table of values here. And so what we're going to do, so first of all, we're going to be looking at, we always start with this function of x squared, and that's just our standard parabola that has not been manipulated at all. And what we're going to do is we're going to apply these transformations right here, okay, just like we did before. But instead of actually doing it as transformations, we're going to go through the table of values. We're going to move the individual points, okay? So what you're going to do is you've got your a value, okay, our a value here. We're going to take, you're going to take your coordinates of x and y, and you're going to apply the transformations directly to those coordinates. So the a value is not going to have any effect on the x. Okay, it's not going to do anything to the x because this is our vertical stretch. So what it is going to do is it's going to affect our y. Whoops. So what we would do is we take that y value and we'd multiply it by the a. Okay, and that would give us that vertical stretch. By multiplying by that a value, it gives us a vertical stretch. And this will make more sense when I do it as an example. Our h value, that's our side-to-side shift. And so this time it's not going to have any effect on our y value, but it is going to affect our h value. Okay, so you're going to take your x value and you're just going to add on that h. Okay. So if you've got it now, keep in mind, it's going to have the opposite sign, so it gets a little confusing because it's inside the brackets there. But if it says x minus 2 squared, it's moving to the right 2. So you're going to add 2 to all those x values. Okay, and then finally our k value, you're going to, again, ignore the x. It's not going to affect our x values. It is going to shift our y value up. Okay, so we would add it to whatever our y value was. Now, one thing that's a little confusing is that we do have two transformations on the y. You would do this one first and then this one. Okay? So, to summarize, because we can just do it as one equation is what we're going to do. So, in other words, we're going to take the x values and we're going to add h. So, we're going to say that our x values become x plus h. But our y values are going to be a y plus k. All right, so in using BEDMAS, we would do that multiplication by the a first, and then we would add the k. Okay, so I'm going to do this example because I think it's going to make it a little bit more simple here. So I've got a table of values showing just our simple, this is just f of x is x squared. So this one hasn't been transformed, and that's what you want to start with. And so we're going to take our x, and we're going to add h. Whoops, don't know what happened there. So then we're going to take our y, okay, and you're going to multiply by a, and then you're going to add k. All right, so if we look at the function here, so we're doing, it's this g of x, so we're going to say, so our h value in this case, our h value is right there, except remember you have to change the sign. So our h value is actually equal to -1. And then our a is -2, and our k is 3. So our h value, our x value is what's going to happen is we're going to have x, and we're going to subtract 1. Okay? Then we're going to have our a, which is -2. So we got -2y, and then we're going to add k. Like that. Whoops, oh, except that, you know what? That's not right, because we know what k is. We're going to add 3. There we go. So we're just going to take each coordinate, and this is what we're going to do. So we had -3. Well, -3 minus 1 is going to be -4. -2 minus 1 is -3. -1 minus 1, -2. And you'll notice the pattern here is just going to be that. Okay? So you can see the x values are the same. We've just shifted them a little bit. We've just shifted them by 1. Okay? Where it gets a little bit more tricky is we are now going to do our y values. A little trick that I like to use is I always like to start with 0. Okay? I don't do this for any reason other than I like to do the simple ones first, and then you kind of spot patterns sometimes. So we've got that vertex at 0, 0. Well, negative 2 times 0 is 0, and then we add 3, so that's going to give us 3. And then we've got 1, so we've got negative 2 times 1 is negative 2, plus 3 is positive 1. Okay? Then we've got 4. Negative 2 times 4 is negative 8, plus 3 is negative 5. Okay? Let's see. And then we've got negative 18. Negative 18 plus 3 is negative... Wait, what did I say it was? It's negative 15. There we go. All right. Okay. And then we can do this the other way. We've got, and these are all going to be the same because, of course, the y values were all the same. From here on, the y values were the same, so they're going to be the same this way, too. Okay, so you're going to get 1, negative 5, negative 15. Okay? So there we go. So let's see. Now all we have to do is we just have to plot these, okay? And they're just sets of coordinates. There's nothing more to that. So some of these won't fit, but I can do negative 3, negative 5. Negative 3, negative 5 is going to go right there. And then we've got negative 2, 1. Oops, there we go. Then we've got negative 1, 3. And then we've got 0, 1. And you can see that it's starting to make our parabola shape here. And then our last one will also not fit. So we're just left with that. Okay? And then, of course, you're just going to make sure you label it. So we say g of x is equal to, I didn't really give myself a lot of room here. That's equal to negative 2 x plus 1 squared plus 3. There we go. And that's it. Okay? So let's try another one. All right. So to begin with, you're always going to start with this x squared, and it's going to be the same every time, and you'll get so bored of doing it because you'll do it so often. But it does become easy because you'll just remember what all the numbers are. Okay? So there it is without transformations. So we're going to apply these transformations here. So again, remember that your h is going to have the opposite sign of what's shown here in the equation. Okay? So, whoops. So instead of having plus 3 for our h, we're going to have minus 3. Okay? Okay. So our h value is going to be negative 3. So we're going to have x minus 3. Okay? And then finally we're going to apply, and you can see this one's used function notation instead of writing a y, and it's the exact same thing. Okay? So we'll just write 2 times whatever f of x is. Remember, that's one variable. That's not two things. It's not an f and an x. It's an f of x. Okay? And then minus 4. Okay? So again, we just go through and we'll subtract 3 from all of these. So we'll get negative 6. We'll get negative 5. We'll get negative 4. Again, these went up by 1, so they're going to just work out like this, and it's always going to be this nice. Okay, this one will be a little bit more challenging, but we have 2 times 9 is 18, minus 4 is 14. 2 times 4 is 8, minus 4 is 4. Let's see, 2 times 1 is 2, minus 4 is negative 2. 2 times 0 is 0, minus 4. And then we're going to have the same thing again. We're going to have minus 2, 4, and 14. There we go. So again, we just plot this on the graph. So we say Negative 614 is not going to fit on this. So we'll move on to negative 5, 4 is right there. Negative 4, negative 2 is right there. Negative 3, negative 4 is going to be right there. Negative 2, right there. And negative 1, 4, right there. And again, 0, 14 is not going to fit. So we draw our lines up like that. Hopefully yours is a little smoother than mine, but that's all there is to it. And then we just have to label our equation. So we've got g of x equals 2 x plus 3 squared minus 4. And that is it. So I'm going to leave the last one as what we're going to do at the beginning of our next period class. And so until next time, go Sabres.